Well, good morning, everyone. Thank you for being here on day 2 of GTC and coming here at 9 a.m. in the morning. My name is Adel. Super excited to be here. I've spoken at previous GTCs in the past, but this is the first time I'm presenting to you guys in my capacity as an NVIDIA employee. So I joined here about 6 months ago and super excited to share with you what we've been up to in the past 6 months. The other reason I'm super excited is because I'm co-presenting with Phil Rogers. For those of you that don't know Phil Rogers, he's the brains behind a lot of the goodness that we're about to present. When Jensen first unveiled NGC a couple of years back, it's Phil Rogers' voice that was leading that demo up on stage. And so he's come all the way from Texas. You will recognize his Texan accent when he starts presenting, right? So I'm super excited. It also helps having a really smart dude present with you, because that way I get to deflect all your difficult questions to him, right? Okay, enough about my excitement. Let's get on with it. So look, you guys are solving for the world's greatest challenges, right? Be it in autonomous driving, be it in driving towards that vision of personalized medicines with genomics or medical imaging, be it bringing AI to the enterprise, or frankly predicting better weather. The reality is these grandiose challenges require massive compute. And that's why we're collaborating, right? That's why you guys are leveraging GPUs. But the other thing is, these grandiose challenges also require different personas collaborating in any given organization across these workflows. This is not an all-encompassing charts. There's many other roles that aren't represented here, be it data engineers, DevOps, image analysts, line of business analysts. It takes a team to derive value out of data science, out of HPC, out of AI, right? And understanding that whilst those different roles have the same objective, their challenges are different, right? And so when you talk about a data scientist, how do we ensure that we're eliminating the mundane tasks, be it setting up the environments, or making sure they're not idle while training jobs are taking place, right? How do we eliminate those mundane tasks and get them focusing on their science, right, the innovative work? On the DevOps or the developer side of the house, how do we enable the developers not to have to learn new skills, to be able to easily take those models that those data scientists have created, right, and invoke them in their applications or in their workflows? And then the system admin side of the house, right, the IT side of the house, that's often forgotten in these discussions, right? How do we enable them to deploy these software capabilities into the data centers? So different roles, same objective, but different set of challenges. Let's talk a little more about those challenges, because understanding those challenges has been fundamental to us announcing and bringing to market these new NGC capabilities. So AI requires expertise, right? There's a reason why there are so many PhDs in this room right now, so many PhDs at this conference, right? This stuff is hard. There was an article recently in the New York Times that talked about how the pressure for AI expertise is going to continue to exist for the foreseeable future, because it takes 4 or 5 years to get a PhD, right? So expertise is very important in building these AI-centric models. Installation. A lot of this innovation is happening in the open source community, right? It's changing very quickly, right? Any changes in libraries or dependencies or in the tool chain can ultimately break the stack, right? So there's a lot of promise and goodness that comes out of an open source innovation, open source community, but there's some backfalls as well. Optimizations. Now that you've set up that environment, it's not just going to run optimally. The same way you have to architect a system, the same way you have to architect a model, requires optimizations to derive that true value. Productivity, that's my biggest thing. The whole point about NGC is about enabling productivity, right? We don't want these high-value resources either waiting on long training times or spending too much time on ETL because their data sets are too large. Right? So how do we enable these data scientists, these different roles, to be more productive? And finally, maintenance, right? Again, system admins, IT side of the house, enabling them to make sure they can deploy that software without having to do any special gymnastics or special treatment of that software. And making sure you deploy that software without breaking anything else in your data center. And so again, understanding those challenges was fundamental in us figuring out what are the next set of capabilities that we're bringing to market. The first thing we're doing is we're sharing our expertise. We're embedding our expertise into NGC. You're going to hear us talk about pre-trained models, right? So that our data scientists don't have to start from scratch. You're going to hear us talk about model scripts and sharing best practices to reach state-of-the-art accuracy in the shortest training times. We're going to talk about industry-specific workflows. Right? So we're sharing and collaborating with our expertise so you guys can go faster. Talking about faster deployments. We've been on this journey for some time now. For the past couple of years, NGC's been a container registry, right? Which encapsulates a particular framework or application with all its dependencies, making it really, really easy to deploy, right? Eliminate those mundane tasks of setting up that environment. But we don't just do that once, right? We don't just do that once. Again, that open source community is moving very, very quickly. So some of our containers are published on a monthly basis. Our most popular containers are published on a monthly basis. TensorFlow, PyTorch, CUDA, MXNet. Right? And we're bringing all those optimizations. Those same optimizations, by the way, that help us win 6 of the MLPerf benchmarks a couple months back. Higher productivity. This theme of expediting training times. This theme of enabling ETL for data processing. Right? Making sure our data scientists are not sat idle at any time. And finally, helping the system admins, ultimately, like the IT side of the house, be heroes of their organization. Aligning with the operating systems they want to deploy in their data centers. Aligning with the OEMs they want to deploy in their data centers. Right? So we're going to be talking about all these themes as we go throughout the presentation. So NGC. NGC up until today has been the place to get GPU-accelerated software containers. Right? And thousands of users have pulled on our PyTorch and TensorFlow containers on our HPC apps. But we recognize that we needed more. And not just more applications and containers. Yes, we're absolutely doing that. But we need to bootstrap these containers with more capabilities to allow you guys to deliver greater value and deliver greater value faster. So what's the first thing we're announcing? Jensen teased this out on stage yesterday. We're announcing a model registry. And we'll talk a little more about that shortly. But I remember when I was shopping this idea around internally at NVIDIA, you can't believe the different places our researchers were storing their models. Right? I've had USB drives, Google Drives, Dropbox, S3 buckets. I think I've even had to shake down people because they've had them hidden in their back pockets. Right? So we're announcing a model registry. Building on that model registry such that if you don't want a pre-trained model or a model that's ready in inference, providing you with model scripts, sharing best practices, how to architect models across an array of different applications, right? Including the very popular BERT that everyone's talking about here, not a character from Sesame Street. And finally, delivering on the Prada promise. Who attended yesterday's keynote? Just a quick show of hands. Yeah? Who can remember what Prada stood for? Programmable acceleration of domains with a single architecture. The key word being domains, right? We really start delivering value, right, when your pipelines, your workflows, your applications are domain-specific. And so in addition to the model registry, in addition to model scripts, we're introducing the very first domain-specific pipelines, be it for training, be it for deployment, right? And so NGC, no longer just a container registry. It's an accelerated software hub, right? A quick view here. I think we got 55 containers as of this morning, more than 50 pre-trained models. When we first created this chart, we were at 10 scripts. As of this morning, we are at 14 model scripts, including my favorite Sesame Street character, BERT. Right? And as I spoke about industry workflows specific to medical imaging and smarter cities. And the value proposition ultimately is about simplifying the deployment, right? So you guys can be more productive and ensure, right, that we're not forgetting the IT folks in the house, right? Bringing them along the journey such that we can deploy those capabilities anywhere. So now we're going to go deeper in each one of those sections. And for that, I'm going to turn it over to Phil to take you through containers. Thanks, guys.
Good morning, everyone. Is the mic on? Good. I'm also excited to present with Adel. Sometimes he makes me feel a little old, like when he gets carded and I don't when we go drinking wine. So we standardized on containers several years ago as the ideal way to deliver GPU-accelerated applications onto servers and workstations. And there are several reasons we chose it. And the first, as Adel already alluded to, is the installation problem. Installing complex stacks on Linux is an adventure at times, and installing several of them and getting them to run together on the same machine, the same server, is also hard and gets exponentially more difficult. So moving from an environment where you install an application to where you simply type docker pull, and that application comes onto the server or workstation, and Docker run with your own parameters to run it, seemed ideal to us. And several years ago, we enabled Docker for GPUs with the container runtime for GPUs. And that gives us a great platform. The other thing that a container does for an application or a framework developer is encapsulation. Everything that app depends on, its executables, its libraries, its environment variables, all dependencies are within the container, and it becomes highly portable because it can run on any Linux machine that has a modern kernel that's Docker capable. And basically, all Linux OSs have been in that shape for several years. So then what did we do that makes NGC containers different? Well, a lot of it comes down to optimization. We recognize that the users on our GPUs care about time to results, right? Everybody's busy, everybody wants to run a lot of experiments, and researchers are at their most productive when they can run multiple experiments per day rather than an experiment every few days. And we've seen that internally as we've sort of turbocharged our own researchers up to getting into that twice-a-day experiment cycle. As well as optimizing for the GPU, we also optimize for scalability. That means the containers that you pull from NGC, whether they're deep learning or HPC, they'll automatically scale out to multi-GPU in a server or a workstation, and many of them scale to multi-node as well, letting you run that single application across a whole cluster in the data center. We recognize that not everybody wants to run Docker. Docker's the preferred container runtime in the enterprise, but many of our HPC centers and supercomputer centers prefer Singularity, and we qualify our containers on both. And it's the portability and the run everywhere promise that really brings this home. We test in our QA every month across a range of GPUs, Pascal, Volta, Turing, Teslas and Quadros. We test on DGX Station and DGX1 and DGX2. And we also test on single and multi-GPU instances at all of the major cloud providers so that when you pull that container from NGC, you can be very confident that it's going to run and it's going to run fast. As Adel mentioned, we've been building out our portfolio of containers on NGC at the same time as we've been expanding to models, model scripts, and industry workflows. So let me talk about that a little bit. On the deep learning side, we've had deep learning frameworks right from the beginning, and we do update the most popular ones every single month. We stay current with upstream, we optimize internally across all of these platforms, and we push our optimizations upstream as fast as we can. Sometimes it can take a month or two for pull requests to get integrated into upstream. But when you're working with an NGC container, you're working with technology that's staying in sync with all of the major framework providers. Soon after we added the deep learning framework containers, we added inference. We have TensorRT to recompile your trained network for deployment at the edge, the Deep Stream SDK to go out to Jetson and Xavier, and TensorRT Inference Server to be able to deploy scalable inference out to the cloud under Kubernetes. We've added traditional machine learning with Rapids and partner containers like H2O. On the HPC side, we've been very busy over the last year and a half. We started with 10 HPC container images, and we've been building out that portfolio. On HPC, this installation problem is even more profound. We have many users of HPC apps within NVIDIA who talk about how this has been life-changing from them. That when they approach a new platform, instead of the first couple of days getting the application installed and working properly, they just pull the container, and in that second hour, they're running productive and they're working on the local system. Those container images in HPC are mostly provided by the academia and partners at national labs. And they've been doing an amazing job of optimizing their applications and providing us with updated containers that we host in NGC for you to use. If you are an HPC practitioner, you know that one of the hardest things about discovery is interpreting all the data that HPC app produces. So HPC visualization lets engineers and scientists immerse in the output of their applications and much more quickly innovate. And for that, we have ParaView, we have the index volume renderer, and the optics ray tracer, and several more. And most recently, we added Parabricks for genomics. We're very excited to have that to bring the NGC container technology to another field. So I mentioned that a big part of the value for NGC containers is performance, time to result. So there are several technologies that we apply to make this happen. One of the key things is you can only get performance out of your GPUs if you can feed them data fast enough. And when a lot of convolutional neural networks and image processing, video processing first started in deep learning, people were running on 1 GPU or 2 GPUs, and all of the front-end pipeline was implemented on the CPU. And this is things like JPEG decode and resize and crop and color contrast and augmentation. And then as we built out more GPUs into servers and workstations, the CPU can't keep up with that. So we solved this with a library called DALI. And what DALI does for you is basically take that front-end pipeline, all of that image manipulation before the training starts, and moves everything beyond the first part of JPEG decode onto the GPU. And at that point, you can scale very easily up to 4, 8, 16 GPUs. And this is especially important as the number of GPUs per CPU socket is increasing. And then this is super exciting. This is really how the GPU can run very, very fast. In deep learning, we really don't need high precision floating point for everything in the deep learning training pipeline. And in particular, for convolutional layers, for anything that runs with GEMS, general matrix multiply, FP16 is plenty of precision for the multipliers. An enormous amount of what goes on when you're processing a convolutional neural network is matrix multiply. Matrix multiply is a series of fused multiply adds. If you put your activations and gradients into FP16, then all of the multiplies can happen in FP16, and you can accumulate in FP32 if you need that range, or FP16 if you don't. And starting in Volta, so in all of the Volta and Turing GPUs, we have this tensor core engine. And this tensor core engine runs fuse multiply add instead of 1 element at a time, 16 elements at a time. And running FP16 into a FP32 accumulator, every streaming multiprocessor can generate 16 results every 2 clocks. That's 8 times the throughput of math that FP32 can do. Now, as you can imagine, working out in a whole neural network how to apply this, which areas it's safe, which areas it might not safe, which areas it would need to be rebalanced, is quite hard. So we've produced a library called AMP, Automatic Mixed Precision, and that has been going into our frameworks to do it for you. It's literally a 3-line code change. 1 line changes, 2 lines get added, you initialize the library, and then you tell the library what optimization level to run. And what we see in actual deep learning training throughput is typically between 2 to 4x gains in performance. Now, not all of that gain comes from the arithmetic. Part of it comes because you've shrunk your model. All of those activations and gradients have come down by half, so it only takes up half the memory. You also get twice the memory bandwidth, but more importantly, you've made space to run larger mini batches, so your end-to-end training time can reduce from both the arithmetic throughput and the fact that your mini batch size goes up. So this has gone into, it's been in PyTorch in a library called Apex for months. It's in the TensorFlow release this month, 1903, from the NGC Registry, and we're working on the MXNet integration as we speak. You might worry that if you're using a different precision, a lesser precision on the multipliers, that your training accuracy might go down, and that's not the case. Right? In using AMP and similar methods, we're able to maintain the accuracy. We do see some very small perturbations, but interestingly, they're plus or minus. Sometimes it comes out just a little bit more accurate, as perhaps the higher accuracy floating point can sometimes overfit. But it's essentially the same accuracy, much faster performance. So the promise of NGC is improved performance over time, where you don't have to update the application you're running, you just pull a new version and it goes faster. And here you see some of our history here over the last year as we've been building up that performance. A lot of the performance gains here are from DALI and AMP, but we've also improved the performance of cuDNN and Nickel, our collectives library for multi-GPU interoperation. And then finally, the last chart is from our HPC applications, averaged across all of the ones in the registry. And you can see our HPC partners have been working just as hard alongside us and supplying us with updated HPC apps that are also riding this performance curve. Back to you, Adel.
Mic's on. All right, perfect. Model registry. Like I said, we announced the model registry, hosting some of the most popular AI models pre-trained or ready for inference. Give you starting points, whether you want to prototype, you want to compare your own model against a standard model, whether you want to retrain an existing model. It's open. You can, as I said, you can use them as is or customize them easily. The other thing we did is for NGC enterprise account holders. So if you're a DGX client, you have a private repo. And I'll talk about this shortly as well. If you have an NGC-READY system with support services, you also get a private repo. A private hosted registry, which allows you to leverage the model registry across your organization, across teams, share models, version models, upload models, et cetera. So adding policy around the model sharing and the model registry as a whole. So we're starting with, I think it's 59 models when I counted yesterday. We've got 2 sets to start with. We've got pre-trained models that are domain-specific for smart cities and medical imaging. And this is fantastic. Phil's going to talk about transfer learning shortly, but fastest way and most efficient way to realize value with deep learning is to start with a pre-trained model and then retrain it with your own data. And that's what we're doing here, right? And for medical imaging, those are organ and tumor segmentations. We also do X-ray classification. For video analytics, it's your basic classification and object detection. But we also have TensorRT models. So we took Onyx models, some of the most popular Onyx models, ResNet 50, VGG16, Inception V1. We've converted them to TensorRT files across different precisions, int8, FP16, FP32. We've also optimized them for different GPU architectures. So a T4 GPU, a V100 with 16 gigabytes, and a V100 with 32 GBs. And we've hosted all those on NGC. Available right now, free for the world to leverage. I'm super, super proud of this. And I've got Matt and Michelle sitting up front here. They're part of our front-end engineering team. This is the new UI. You can take pictures, or you can just go to ngc.nvidia.com to see all this live. We created this chart before we went live yesterday, so there's some mock-up data, which is why you guys are giving me smarks up here. But this is all live now, right? And the idea is, people ask me, hey, Adel, why are you, launching a model registry? Why do you have a Docker, or a container registry? I'm not competing with Docker Hub, right? I'm not competing with GitHub. We're not competing with AI model zoos, right? But the value of bringing a set of curated assets, NVIDIA assets, some of our best assets across deep learning, machine learning, collectively into one spot, and providing an awesome UI and a user experience to navigate that entire experience, that's the value that you get from NVIDIA, right? And so, there's a UI, you can download, look at different overview sections, different tabs. You go to file browsers to version models as they go across time. And one of the things we're going to be doing very shortly is relating model scripts and models, right? So I compare this to, you get a test, and you get the answers on the back of a test, right? So you try the test out yourself, you see how you did, then you compare it to the optimal answers, right? And that's what we're doing with a model registry and the model scripts, right? So model scripts, I spoke about this earlier. The race has been on to how do I train to state-of-the-art accuracy in the fastest time, leveraging AMP, leveraging DALI. We give you those guided instructions, right? We give you those guided instructions. Which container to use, what data format to use, how to download the data, right? What learning rate to set. We provide all that guidance in the form of model scripts. And they span all sorts of different applications. NLP, classification, recommendations, translations, et cetera. Right? This is a mock-up, actually, but the new UI has actually got, or the live UI has got even more than the amount that we represent here. And again, the same thing we did with our model scripts, right? It's very intuitive. You can navigate it easily. You got your file browsers. And over time, right, we're going to be posting the outputs of these model scripts on the model registry as well. Right? Super, super excited about this. Again, if you get a chance, make sure to come thank Matt and Michelle that are sitting up here in the room.
So let's look now at how all of this goodness that we've got hosted can be put together and used in real industry applications. A lot of industries use a workflow that basically looks like this. This is a transfer learning workflow. The idea is you start with a pre-trained model like the ones that we're supplying in the NGC model registry. That model will have been trained on public data, but most customers want to produce a model that they're going to deploy that's also been trained on their own data. They don't want to necessarily start from scratch. Training a model from scratch can take weeks or months. We've put a lot of iteration into the pre-trained models that we host. But you can start with that pre-trained model, bring in your own data, and retrain that model in order to work with the data sets that your application is going to see. That involves training on that new data, then optimizing the network, which often involves pruning. And once you get that prune network down that will run faster on inference, you have to retrain that prune network to get the accuracy back to what it was after training with that new data. This can be a cycle. A lot of industries and applications bring in new data every day, every week, every month, and you continue to refine. But any time that you're ready to deploy, you have an optimized output model that has been retrained in this pipeline, and then you want to deploy to the edge or to a data center to scale out. And that involves running TensorRT to recompile the model. You might take the model down from FP32 to integer or to FP16, and then deploying out to different devices depending on your industry. So this is a blueprint that applies in a lot of places, but it would be a huge amount of work for any individual customer or industry to take this and tailor it instantly to their application. So we've provided two start points for industries in NGC as of today. The first one is for NVIDIA METROPOLIS. And this is a pipeline that's set up for intelligent video analytics for smart cities. So this could be analyzing traffic at an intersection or optimizing parking across a set of parking garages, or finding a lost child at an airport, right? All of this can be done with IVA. So the transfer learning toolkit works with video data. It's able to start with a pre-trained model, retrain on all the local video data that the customer provides, train, prune, tune, repeat, right? And that will then produce an output model that's ready to deploy. And then for IVA, the deployment vehicle, also in NGC, is the Deep Stream SDK. And the Deep Stream SDK is set up to recompile that network and be able to deploy it out to Jetson-enabled edge devices and video cameras and other devices of that sort. And what you can see at the end of that pipeline, once we have deployment, this network was trained to do object detection and pixel segmentation. And then at inference, you can see that on a live video feed coming in from a video camera, in this case, it's vehicle detection. Each vehicle has been identified and then segmented and outlined. And of course, with a deployment mechanism like this, a lot of more intelligence and analytics can be built into that back end to do alerting when something unexpected or unwanted is seen. And now here's a very different deployment, and this one is for medical imaging. This is the NVIDIA CLARA AI platform, and its application is organ segmentation for medical imaging. And this works whether it's a CT, an MRI, an ultrasound, X-ray. Hospitals and medical institutions all over the world have this issue where they're working with instruments that may be several years old that don't have the latest image enhancement technology. But if you bring deep learning and AI and augment segmentation technology, then we can provide output images to doctors and diagnosticians that are much more enhanced and easier to read. How it works is we provide organ segmentation pre-trained models in the NGC registry that are trained on public data. There's a medical segmentation decathlon data set, and we've got award-winning accuracy across that data set in all of the models that we've posted. But as always with transfer learning, training on public data is not enough. So those pre-trained models become an input for a medical institute that then can retrain with the local data sets that they've collected from patients that can't be shared publicly, obviously for HIPAA and other privacy reasons. Very often those scans are not annotated, so we provide AI-assisted annotation to automatically or at least guide on the production of the labels for those. Then we can do that transfer learning, tune, and output a model that's ready for use with a medical device. And then to deploy that out, we have the CLARA Deploy SDK. And this can deploy onto any workstation or server at the hospital with Quadro or Tesla GPUs. And the way it works is when the scan comes in, it will be in a format called DICOM, which is a standard that hospitals use. And the pipeline in the CLARA Deploy SDK will decode that DICOM image. It'll do CT reconstruction. It'll do all kinds of data prep to get that image ready for inference, run the inference, and then run a streaming renderer that will take the segmentation information and color code it out. And I think you can see in that kind of image, the doctor or diagnostician is given much better data from which to then make a diagnosis. So we think this is a lot of value that industries don't have to work out how to do this from scratch. This becomes a kit that becomes a jumpstart for their applications, and they can innovate on top of this.
Thank you, Phil. I'm bringing us home here. So that was Prado, right? Delivering on that domain-specific industries. So we talked a lot about the content that we're delivering with NGC. I want to pivot a bit now to talk about the consumption models, meaning where does this stuff run? I'm super pleased to announce that all the OEMs that we have up here have T4-based systems and V100-based systems in market today. These guys are all selling GPU-enabled systems, right? So you pick your favorite OEM, you've got a GPU-enabled system that's part of it. The NGC-READY program, which we announced back in November, is a validation process of the NGC containers on those given platforms. So there's a whole process in terms of where we validate those systems for both functionality and a performance perspective, enabling you basically to seamlessly pull these containers with confidence and know that they're going to run at a certain performance level and at a certain performance level. And the reason we've got multiple GPU architectures is because they each satisfy different needs, right? V100 systems, I always compare those to a hammer, right? Their performance. They do specific things really, really well. You're doing deep learning training, you want to go with V100-based systems. T4, I compare it to more of a Swiss Army knife, right? It's that utility. Lots of different workloads that can run on that flexible system. And so we've enabled our OEMs, because we believe it's a hybrid model out there, we've enabled our OEMs with all the NGC containers through this validation and certification process. But we don't want to just leave you guys hanging dry either. Right? So today we're announcing NGC support services as well. So for any of your NGC-ready systems, right, you can buy through that OEM NGC support services, where you get access directly to the NVIDIA experts, phone, web, tickets, et cetera. Right? So really enabling this to be enterprise ready. And by the way, we've enabled two types of stacks. We've got an Ubuntu stack and we've got a Red Hat stack. Because again, we heard our on-premises and enterprise clients tell us, hey, right, it's great to do Ubuntu in the cloud when you're innovating, but we want to bring this on-prem. Right? Red Hat is the operating system of choice on-premise. A lot of our partners have announced or are announcing shortly this availability of this offering through their platforms. So bringing us all together. Right-hand side represents the content that's up on NGC. We started with the container registry. We're delivering models, model scripts, and industry-specific pipelines, the product promise. On the other side of the chart, depending on where you're viewing it, right, is all the consumption models. You can run it anywhere. This is truly a hybrid play. Not just the NGC-ready systems, your DGX platforms, right, all of which have NGC support services, but any of your favorite cloud service providers. Right, we've got the equivalent of AMIs or cloud images already set up with all the cloud service providers. Deploy those AMIs on your favorite EC2 instances or et cetera, right, and pull any of the containers that run seamlessly. The other thing, which I didn't touch up on, just in the interest of time, is we're enabling all this through UI. We've also got CLIs, right? You can, if you're a coder or instead of a clicker, we've got CLIs to engage with that content as well. Final chart here, the new NGC. It's all about simplifying deployments, right? Bringing pre-trained models, the model scripts, the industry solutions, so that you guys can innovate faster, right? You guys can focus on the research, solve those grandiose problems, which is where we started this with, and be able to deploy this anywhere, right? Bring the compute to where your data is. Right? In this world of privacy, increasing GDPR compliance needs, right? Having a hybrid solution is fundamental to our strategy, which is something we've enabled. So don't just take it from me. Check it out yourself. This is the landing page you're going to get when you go to ngc.nvidia.com. I urge you guys to please go there. Don't go there on your phone. Right? We're not mobile optimized. I don't know of any folks that pull containers via the mobile. We'll get there if you guys think it's important. We've also got a web page that's up and more technical info on our developer portal. I do want to put this slide up. Some key sessions that will be happening across the coming couple of days. I'd say tomorrow's latest deep learning framework container optimizations, don't miss that out. That's happening from 9 to 10 from Micah Connors and Joey Conway. And please, 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 we have an NGC user group meetup happening tomorrow. That's basically an excuse for us to get together and have a few drinks and talk, and collaborate. So urge you guys to please sign up, or just can they just come, Angie? They could just come. Nobody's going to turn you away, right? And I think that's it, by all means.